let's talk about definitions real quick. Dilation, we talked about, gets bigger or smaller. Oh, so right, bigger or smaller. Why are you? Okay. With dilations comes a scale factor. What do you think a scale factor is? Bless you. What do you think that has to do with the dilation? Right, how much is changing or how big it is. Okay, so with the scale factor, we have 3 options. Okay, let's put a definition first. How much it's changing. So how much it's getting smaller or by how much it's getting bigger. So let's talk about there's 3 different options that could happen. One option, it gets bigger. One option, it gets smaller. What's the third option? Stays the same. Okay, so I'm going to treat our scale factor as x right now. If x is greater than 1, what do you think is happening? So if our scale factor is greater than 1, is it going to get bigger or is it going to get smaller? It's going to get bigger. We're going to call that an enlargement. Okay, using mathematical terms, instead of saying bigger, we're going to say enlargement. Okay, make sure we're writing all this down. So now if x is less than 1, what's happening? Is it getting smaller or bigger? Smaller. It's getting smaller. What's another word we can use for getting smaller? What did you say? No. No.
I don't know.
Starts with a R.
What?
Reduce. Reduction is what we're going to use. Okay, so if it's getting bigger, if our scale factor is bigger than 1, it's enlarging. If our scale factor is less than 1, it's reducing. Okay? Give me a number that's less than 1 without going negative.
0.
Okay? Let's talk about that real quick. If x equals 0, right, 0.49, 1/2, 0.5, all of that stuff. Okay? If x is 0, what's happening? Nothing. It stays the same. Okay? So if x is greater than 1, like 2, 5, 10, anything, it's enlarging. If it's less than 1, like 1/2, 1/4, 0.5, it's a reduction. And if it's 0, it stays the same. Nothing's happening. Okay? Questions about those 3 scale factors? Okay, let's put it to use on this example right here. It says to dilate, so what do we know about dilate? What's going to happen? It's going to get bigger or smaller, okay? Scale factor is 2. Why do you say it's going to get bigger? It's greater than 1. What's the word I want you to use? Enlargement. Okay, so that's step 1. This is an enlargement. So we know that our second image has to be bigger than what we started with. Okay, so how do we figure out the coordinates, the new coordinates? What? If you put it up by 2, you would think of a translation, kind of. Same thing, you would kind of think of a translation. You're really close. So what are my coordinates for A? 0, 4. Now the scale factor is 2. We want to change that by 2. What operation do you think is going to happen? We're going to multiply by 2. Because we're changing it by a scale factor of 2. So if I multiply by 2, we're going to take each term times 2. Remember parentheses? We kind of distributive property, remember way back when? Okay, so 2 times 0 is 0. 2 times 4 is 8. That's my new A term. Go graph it. What do I label my new points?
A prime.
Yep, A prime. So now, how do we find B and C? Same thing. What are my B coordinates?
Like 2.
2, negative 2. What do I have to do? Multiply by 2. 2 times 2. 2 times negative 2. Negative 4. And then C. Looks like negative 3, negative 3. Multiply by 2. What are our new coordinates?
-9, -6.
-6. -6. And then lastly, what do? Connect. How can you check yourself if you did it correctly?
Divide.
What'd you say?
Divide them.
You can divide them back by 2. You can take these, divide them by 2. But just by looking at the picture, how can you tell?
The shapes are same.
Questions after our first example. All right, flip it over. Let's look at another one. So dilate the figure by a scale factor of 1/2. It says dilate, so what's going to happen? It's going to get bigger or it gets smaller. Okay. Scale factor is 1/2. What do we think?
Reduce.
It is a reduction, but why?
Because it's less than 1.
It's smaller than 1. If you don't like dealing with fractions, okay, what can I turn that into? 0.5. And that's less than 1. Okay? So, how do we find our new coordinates? If I have k, what are my k coordinates? K is -6, 3. Are we going to multiply by 2? We're going to multiply by 1/2. What else can you do instead of multiplying by 1/2? You can multiply by 0.5. I can also divide it in half. Divide it by 2. Yep. If you decided to multiply by 1/2 or divide by 2, you'd get the same thing. Okay? So if I divide all these by 2, what's -6 divided by 2? -3. What's 3 divided by 2? 1.5. So, graph it. Is it going to be very nice to graph that? No, that's okay. Dilations aren't always going to end up nice. Okay, so you're going to end up -3 somewhere in there, halfway in between. So now you want to do the same thing for all of them. Go do that. Again, it's okay if you're not done. How can you check if you did it correctly? You could go backwards, okay? We said what at the beginning? What was supposed to happen? We said reduction, so which means get smaller. Is that what happened in our picture? Yes. And does it look similar to what we started with? Yes. Okay? I want you to think to yourself first, real quick. Again, it says dilate, so we're either getting smaller or bigger. I want you to think to yourself whether you think it's an enlargement or a reduction.
That'd be 1.5. That's more than 1.
Okay, so 3.5. Let's take 3.5. Some of us see automatic, that's a fraction. That's a reduction. Can we automatically assume that? No, because what have we learned about improper fractions? They are mixed numbers, so this would turn into what? 1.5 or 1.5. Okay, so since it's bigger than 1, what is it? It's an enlargement, which means our image is getting bigger. So if I have R, what are my coordinates for R? 0, 6. What? Since we're getting bigger, what do I need to do to get my new one? Multiply by 1.5. What's 0 times 1.5? 0. What's 6 times 1.5?
9.
9. And then plot it. 0, 9. And then you would do that to each term. Again, is it okay if they don't end up exactly? Yes. Okay. Now what? We got to think backwards. Okay? First, we have to decide which one's my original image. Which one's the original? The outside. The bigger one is our original. So if the bigger one's the original, is it an enlargement or a reduction? It's a reduction because we are getting smaller. Can we just say a reduction and be done with it? Why not? We have to find the scale factor. We have to know how much it's reducing by. How do you think we do that? Yeah, let's start with the original. It doesn't matter which points I use. So I'm going to pick G. What are my coordinates for original G? The original G is -4, -2. What are my coordinates for new G? -2, -1. So how can I figure out what the scale factor is from those? I'm going to divide them. Okay, so I can take my x values, my -4 and -2, divide those. -4 divided by -2? 2. Does it matter? Should I get the same thing if I do the y's? Yep, do I? If I divide those? So it is a reduction by 2. Reduction by 2. Okay, go try that last one by yourself. Second image, right? Those primes are our second image. So our original one was that smaller one. So if we go from smaller to bigger, what's that word? Enlargement. Yep. Can I just stop with enlargement? No, we got to figure out how much is changing. How do I figure out how much? Pick one. A, B, C, or D? D. I heard D first. D, what is my original coordinates of D? -3, -1. What are my new coordinates of D? -9, -3. Okay. What'd you guys get for your enlargement number? Enlargement by 3. Questions? All right.